This is Chapter 8, Section 8.1a, Part 1. So in this section, we're going to be learning about trigonometry, particularly the sine, cosine, and tangent rules for right triangles. So the first thing we need is to be able to label our triangle properly. So in all of these cases, we're always talking about right triangles. So what a right triangle is, it means that one of the sides has a 90-degree angle. So that means that this is straight up and down, and this is straight horizontal, and they meet at a 90-degree angle. Usually, the 90-degree angle will be indicated with this little square, but it's not always written there. Sometimes you have to just look at it and see which one looks like 90 degrees. Okay, so what you're going to do in this case, you're going to circle the 90-degree angle, and you're going to draw a line across from it, and you're going to write hypotenuse, H-Y-P. Okay, so the hypotenuse is the longest side of a right triangle, and it's always across from the right angle. So here we have our right angle. Across, we have our hypotenuse. Next, the opposite side. So the opposite side is the side opposite the target angle that does not touch the angle. So to figure out what the opposite is, first we need to know what the target angle is. So in this case, it's the one that has the little angle sign here, okay? Sometimes the target angle will have a sign like this. Sometimes it'll just have a number. Well, it wouldn't be 90 degrees. Let's say 70 degrees, okay? There'll be some indication as to what the target, which one you want to use for the target angle. So some indication in the picture. Let's use green. So I'm going to circle the target angle. I'm going to go across from the target angle over here. And this is going to be my opposite, OPP. Okay? And then I have one side left over. So that's the side that is next to the target angle that does touch the angle, and that's not the hypotenuse. So basically it's the one side that I have left over, and it should be next to that angle if I've done everything right. Okay, so the opposite side here, it's opposite the angle, doesn't touch it at all. Hypotenuse we always do first. It's the one opposite the right angle. And then my last one is adjacent, and we'll write ADJ for that one. Okay? So we name the sides of a right triangle, and like I said, something with a 90 degrees, in relation to one of its acute angles. So one of the angles that is not 90 degrees. Okay? So these are our three that we need. Opposite, hypotenuse, adjacent. So we can try and do that over here. So we're going to start with our right angle. We're going to circle it and draw a line across and write hypotenuse. Then we're going to find our indicated angle. So in this case, our indicated angle is this one right here. And across from that is going to be opposite. And then the angle that we have, or the side that we have left over that does not have a label, is going to be adjacent. So that's how we label opposite, hypotenuse, and adjacent on our triangle. In a right triangle, if the angle is the same, the ratio between the sides are the same. So we have our three trigonomic ratios, okay? To find out the sine of an angle, we're going to use opposite over hypotenuse. So in this case, we'll use this side over this side, a ratio of these. So let's say this is 5 and this is 10. So this would be 5 over 10. Next we have cosine. Cosine is adjacent over hypotenuse. So adjacent over hypotenuse. So let's say this is 4 and this is 10. So then this would be 4 over 10. And last we have the tangent. So the tangent is opposite over adjacent. Okay, so again, what did I say? This was 5 and this was 4. So this would be 5 over 4 for that ratio. Okay. The best way to remember these three ratios is to use the phrase SOHCAHTOA. Sine, SOH is, so this is the SOH, S-O-H, SOH. Sine is opposite over hypotenuse. CA is cosine is adjacent over hypotenuse. And then TOA. Tan is opposite over adjacent. SOHCAHTOA. Okay, this is a common phrase for trigonometry. So just to test now, so that you can actually figure these out in your calculator, you need to use a calculator to write these trigonometric ratios in decimal form. You need to make sure that your calculator is in degree mode. So normally if we were in the classroom, I would help people with this because some people can find this tricky. But on your calculator, let's say this is your calculator. This is the screen where the numbers are. You need to see a little thing that in tiny, tiny letters at the top that says degree, or sometimes it's just a D, or some calculators just like mode 2, okay? If you don't know, so if it'll indicate degree, if it doesn't say that, you need to look either, sometimes it'll say on the back of the calculator, the manual that it came with, or you need to look it up online and figure out how to change to degree mode. Okay, so your calculator needs to be in degree mode, otherwise you're going to get wrong numbers for this. Okay, so now you need to be able to actually put this into your calculator. So you should see separate buttons on your calculator that say sine, cos, and tan. Okay, and they'll be in different places depending on the calculator that you have. But there's a button for each one. So here, sometimes in some calculators, you press the sine button first, and then you put the numbers in. So you would press the sine button, and then you do 35, and then enter. Okay. Some other calculators, you type in 35 first, and then you push the sine button. Okay. So you have to figure out what it is in your particular calculator. So when you do that, it says here to 4 decimals. So when I put the sine of 35 in my calculator, I get 0.5736. For this one, the cos of 35, so here I would type in 35 and press the cos button, or press the cos button first and type in 35, depending on the calculator, 8192, and then this one is 0.7002. So you should have these 3 answers. If you round it a little differently, that's not a big deal, but in general, it should be this number. If you did not get this as your answers, it means that you're doing something wrong with your calculator. Either it's not in degree mode, you're not using your buttons correctly, and you need to do some troubleshooting, okay? So, so make sure you're getting these as your final answer. Next, we need to be able to use a calculator to solve for, this means angle, for the angle to 1 decimal place. So here, we have our buttons, okay? Now we're going to be using sin to the -1. So this is like the way square root and is the, I don't know, how do you say opposite? Whoops. It's not equal to. Square root is the opposite of like the square. Okay, square root and square. Well, sine and sine to the -1 are opposite of each other, okay? So to get the sine to the -1, usually calculators somewhere up here will have a second button, okay? A second button. So, and if you look right above your sine button, there should be in tiny little text sine to the -1. And it'll be in a certain color, and it should be the same color as the second button. Or sometimes maybe there's another, like let's say this is a yellow button, sometimes an orange one. I don't know. Depends on your calculator. So normally what you would do is you would look at the tiny text right above and look for sine to the -1. And you would press second and then sine to the -1. Okay? So let's try this out. So here, if we want to get angle, our angle, we're going to do sine to the -1 of 0.5687 is equal to. Okay. So depending on your calculator, you're either going to do second sine to the -1 and then type in 0.5687 and then hit the equals, okay? Or you're going to type the number in first and then you're going to press second sine to get the sine to the -1 and then press equals, okay? And you should get an answer of 34.7. And we can put the degree sign on there, okay? For the next one, so we want angle here. This is with cos to the -1. Same thing, 5687. So now, if you put second cos, put this number in, you should get 55.3 degrees. Okay, and the last one, we're going to have tan to the -1, 0.5687. So this one, we're going to second tan, we'll put this number in, and we should get 29.6 degrees. Okay, so you should get this. These should be your answers for each of these. Okay, if you're having trouble finding these on your calculator, okay, if you're having trouble finding any of these answers, then you need to either ask someone for help, so maybe a parent in your house, or you can look up a YouTube tutorial on this, or you could message me, but you need to be able to figure out how to use these calculator buttons properly, okay? Otherwise, you won't be able to proceed after this. Okay, so I'm going to assume you've figured out your calculator, and now we're going to move on, okay? So why are these trigonomic ratios important? Well, we can use these trigonomic relationships between angles and sides of a triangle to find missing pieces of information from our triangles. So we can find missing angles, and we can also find missing side lengths. So let's start off to find a missing angle. So here's our triangle. We have a little box, meaning that this is a 90-degree angle, okay? And then we have no angle here and no angle here. And they're saying we want to know what this angle with the little sign is. Okay, they're saying find this missing angle. We're not caring about this one right now, but they want us to find this. Okay? So our step one is to label the triangle using hypotenuse, opposite, and adjacent, and using the missing angle as our reference angle. So that's the first thing we're going to do. So we're going to circle, go across. This is our hypotenuse. Then we have our target angle. We're going to circle that, go across, and this is our opposite. And then the last angle that we didn't circle yet, that's our adjacent. Okay? So that's our step one. Next, we need to choose the trig ratio that matches the sides given and the setup for the equation. Okay, so what does that mean? So what we're going to do is we're going to, in this case, circle our labels that have pieces of information next to them. So here, our hypotenuse has a 15 next to it. So we're going to circle that. And our opposite has an 8 next to it. We're going to circle that. We know something about the hypotenuse. We know something about this opposite side. We know this is 15. We know that this is 8. We don't know anything about this adjacent, so it's not very useful to us. So to be able to find this angle, we have two pieces of information. We want to know the angle. So that means that these are the two pieces of information that we're going to use. We're going to look back at our ratios, our SOHCAHTOA. Okay, and we're going to find out which one uses opposite and hypotenuse. So opposite and hypotenuse is this first one, so that's going to be sine. So we're going to write out, so op and hypotenuse, so we're going to use our sine. So now we're going to write out what the sine ratio is. Sine of an angle is equal to opposite over hypotenuse. That's our formula, so we're going to write down our formula. And then we're going to pop in the information that we know. So we don't know anything for our angle, so we're going to leave it like that. But we do know that opposite is 8. So opposite here, we're going to fill in with this, 8. And we do know that our hypotenuse is 15. Okay? Now, we want to solve for this angle. We're trying to figure out what this angle is. So we don't want the sine on this side. We need to move it over to the other side so we can isolate the angle by itself. Okay, so when we move the sign across the equal sign, we do the opposite of it. So now we just have angle. So the opposite of sine is sine to the -1, 8 over 15. Okay, so now you're going to put second sine 8 over 15. Sometimes you have to put it in brackets. The 8 over 15 is equal to, and it should give you an answer. Or some calculators, you do 8 over 15 equals first, and then second sine of that is equal to. Okay, it depends on your calculator. So you need to learn the intricacies of your calculator. And 32.2 degrees. So this missing angle here is 32.2 degrees. Okay. Next one, we have another triangle over here. So we're going to start off the same way that we label. So circle here, draw it down. That's our hypotenuse. Next, we're going to look to see if they indicated an angle on here. They have right here. Draw across and say that this is my opposite. And then whatever is not labeled, that's my adjacent. Next, I'm going to circle the two sides that have numbers next to them. This one and this one. So I have opposite and adjacent. I'm now going to look at my ratios over here, and I'm going to find the one that has an O and an A. So the TOA is O and A. So that means tan. So op plus adjacent is tan. So now I'm going to write my tan equation. Tan of an angle is equal to opposite over adjacent. I'm going to fill in the information that I know. Tan of an angle is equal to, for opposite, I'm going to look and see what piece of information I have here. So it's a 9. I'll fill in 9. Oops. For adjacent, I have a 13. So I'm going to put a 13 on the bottom. And then I'm solving for this angle. So that means that I need to move the tan over to the other side so that the angle's by itself. So I'm going to do the opposite of tan, which is tan to the -1, 9 over 13, like this. So now I can put this into my calculator. I can do depending on your calculator, tan to the minus 1, open bracket, 9 over 13, close bracket, is equal to, or I can do 9 over 13 equals tan to the minus 1. Whatever way you do it, you should get 34.7 degrees. Okay, so now, oops, what's the homework for this? Oops. 1.A worksheet. Oh, okay, so it's right here. So now you're going to, at this point, do find the missing sides. This is all, find the measure of each angle. Okay, so you're going to do number 1 on this page. So 1A, B, C, D, E, F. So you do worksheet 1A to F. Okay, and then we're going to come back and I'm going to show you how to find the missing side length in part 2.